Okay, this is 8.3 area of sectors. I'm skipping these couple 3 review problems at the top. Notes are posted and we have went over this before. So I'm just trying to make the video quicker. So I'm starting right here with the definition of a sector. So a sector is a portion of a circle bounded by a central angle and its intercepted arc. So here's your central angle and here's the arc. Okay, it's always shaded. Think of a sector kind of like a slice of pie or pizza or cake, whatever. Where central angle, a sector is always the shaded part. Okay, it's always shaded. Area of a sector is just a fraction of the entire area, because first we find area, which is pi r squared, and then we always take whatever our x over 360 is times it, because we only want, first we find the whole area, but then we only want this little piece, so we just take it times that little fraction of that degree. Okay, so here's our formula for area of a sector. So we can write the way I just wrote it on the others, on right here, where you take your area times that fraction, or you can make it one big fraction. So we can have x times pi r squared all over 360. Okay, or you could take it times your area over 360. So r is for radius, x is for angle, a is for area of whole circle. Okay, first problem. So we want to find the area of each shaded sector and round to the nearest tenth. So here's our sector. Okay, our r is 16, that's our radius. Our x is 51. You're always finding the area of the shaded part. So we always want the shaded. So we take 51 times pi 16 squared over 360, and we get 113.9 feet squared. When you're typing these in your calculator, make sure you're using parentheses around the top part of your fraction. So if you have the special calculator that does fraction buttons, make sure it's all on the top, or make sure you have everything in parentheses. So in PQ, so in number 2, PQ is your R, so this is 22. That's your R. Your X is your degree. So we take 139 times pi 22 squared, all divided by 360. And the area of the shaded region is 587.1 centimeters squared. Okay, it's area, so make sure you have units squared. Okay, our next one. So we want the area of the shaded region. Shaded is this part out here. So we have to do 360 minus 42 to get that area of that shaded region, which is going to give us 318. So that's your x. The YZ, that's your r, that's your radius. Okay, so put it in the formula. So area of the shaded region is 318 times pi 9 squared over 360. Plug that in your calculator, you get 224.8 inches squared. Our last one, again, we want the shaded region. So shaded is the 29, so x is 29, r is 32.5. So plug it in your formula. Again, all of this is just formula work. So 29 times pi 32.5 squared over 360. If we plug that in, we get 267.3 feet squared. Again, make sure you're only squaring your radius and that all of this is divided by 360. Number 5, so if we are given 2 shaded regions, we want to find the sector, we want to find the area of both of these sectors together. remember, we got vertical angles. So vertical angles are congruent. So this is also 46. So your x is equal to 46 plus 46. So you get 92. HG, that's our radius right here. So this is 7. So R is 7, so plug it in. So area is equal to 92 times pi 7 squared all over 360. Plug that in our calculator, we get 39.3 centimeters squared. When I say plug it in and use parentheses, I mean type it just like this. So we say 92 times pi times 7 squared divided by 360. So we want only the 7 squared, and all of this has to be divided by 360. Okay, our last one. So we want to find the area of the shaded region. Well, this is all 180, remember? Straight line is 180. So x is equal to 180 plus 58, which gives us 238. JM is the whole thing. Whole thing is 10. So JM is your diameter. Remember, diameter is equal to 2 radiuses, so our radius is 5. So plug everything in. So area of the shaded region is equal to 238 times pi 5 squared over 360. So our area of the shaded region is 51.9 millimeters squared. Okay, make sure you, again, don't forget units. Okay, don't forget your units. And that is the end of section 8.3.